all right, let's do it. Hey, welcome back. This is Linear Functions Word Problems. Practice this. If you're not subscribed, please do so. Throw a like. Download this free PDF. It's in English y Espanol. Get some math going, and then come on back and do a little bit with me. All right, here we go. The cost of a graduation party is $30 for the cake. Okay, so that's important information. No matter how many people show up, the cake's going to cost $30. And $3 per person. Notice that word per, right? That means rate of change. So $3 per person. So the cost of your graduation party is $30 for the cake and $3 per person. For the party, per person for the party favors. Woo woo! Your dad says you can invite a maximum of 20 people. Okay, so that is your maximum input value, which we call the domain. Let's write a cost function. So I'm going to write a cost function, C of x. Notice I chose C of x because down here in the table, that was the name of the function, C of x. And also C makes sense for cost, right? Okay, equals. Now what does that equal? That equals the rate of change times every person that shows up. So x represents the number of people that show up, right? That's what that represents. And no matter how many people show up, it's going to be $30 for that cake. So this is the cost of your party. Determine if the function is continuous or non-continuous. That means discrete. All right, this is non-continuous because you can't have a half of a person or a third of a person or 7.2 people show up. They got to be whole numbers, 1, 2, 3, 4, 5. So, at a maximum of 20. State the minimum and maximum input values. Okay, your minimum is 0. Ooh, you're having your party during the Super Bowl. Bummer. So that's 0 people. And your maximum is 20 people. That's what your dad said. You can have as many as 20. All right, let's hope you fill that place up. Okay, now let's make a table of values. Find 3 ordered pairs. Okay, this isn't bad. Always include your minimum input and your maximum input. And then pick one in the middle. I'm going to pick 10. It just kind of popped out at me. So now I'm going to go to my function. And I'm going to put in these different values. Well, if I put in 0, 3 times 0 is 0 plus 30. So that's easy. Just have to pay for the cake because no one showed up. Well, what about 10 people? Well, now if 10 people showed up, it's going to be 3 times 10 because $3 per person. So that's $30 for the people plus $30 for the cake. Woo! Now if I do 20, oh, I wish you would have saw all of that. I wish you would have saw all of that. Now if I would have do 20 of those peeps, then I'm going to go here and I'm going to say 3 times 20 because I'm inputting 20 into the function, right? I'm putting 20 in for the number of people, x, plus 30. That's $90. Okay, that's not bad. Okay, number of people. Let's see, 2, 4, 6, 8, 10. I'm going to do increments of 2. So 0, 2, 4, 6, 8, 12, 16, and 20. That fit nicely. The cost, the cost is 90. I got to go up to $90, so I'm going to do increments of 10. I like nice even increments. It's just nice. 10, 20. So there's 20, 30, 40, 50, 60, 80, and 100. Okay, let's plot some points. 0, 30. No one showed up, but you still got the cake. At least you got cake. Now I'm going to do the 20, 90. That's going to be right here. And then I'm going to go ahead and graph the function. Remember, it's discrete, so I'm going to make a dashed line to show the reader that not all values between 0 and 20 are valid. We're restricted. You can only have numbers that are whole numbers. 1, 2, 3, 4, 5. All right? And 0. Okay. Now notice we had another ordered pair, 10, 60. 10, 60. Boom, right there. I like to kind of use that ordered pair to check to see how we did sometimes. That looks good. State the minimum and maximum output values, the range. Okay, the minimum output is $30 because if no one shows up, it's going to cost $30 for the cake. So you still got to pay for that no matter what. The maximum is if all 20 people show up that you invited, and that's going to be $90. The rate of change is $3 per person, right? It's in the problem. That's your rate of change. Notice the unit of measurements, $3 per person. At the y-intercept, determine the number of people who attended. Well, the y-intercept, is right there. Notice the input x is 0 at the y-intercept. So 0 people. Find the cost when 20 people attend. We already did that. It's in the table. $90. Find the number of people who attended if the cost of the party was $180. Hold on. That goes beyond our domain. That goes outside of our range. Okay, so that is outside of our range. So this would be extrapolation. Now we'll figure it out, but it's not within our guidelines for this function. All right, so we're extrapolating. So I'm going to go to the cost function, and I'm going to say 180 equals 3x plus 30 minus 30 minus 30, and that's going to give you 150 equals 3x. Divide by 3. Ooh, Daddy ain't going to be happy. You invited way more people than he said. Way more. Oh, you're going to be doing chores for a while. Okay, let's go to the next one now. Okay, here we go. Amy planted a 5-foot maple tree that grows at a rate of 2 feet per year. Okay. Well, look at this. Her tree continues to grow at this rate for 40 years. Okay, we have a lot of information. Notice the day Amy planted the tree, it was 5 feet tall. Notice the tree grows at a rate, it's a very important word, of 2 feet per year. That's your rate of change. 2 feet per year. And also notice they gave us a maximum input of 40 years. 40 years. Okay, write the function that represents the growth of Amy's tree. Again, I'm going to look at my table, and I notice the output variable is h of x, input variable is x. In a table, this is always your input, the first column, and your second column is always the output. So, we got h of x equals your rate of change, that's 2 feet per year, plus the initial height. That is the years that the tree has been growing. Okay, so you got to know what that input is. This represents the output, which is the height of the tree after however many years it's been growing. All right, determine if it's discrete or continuous. This is continuous. The tree doesn't just pop up 6 inches, 12 inches. It is continuously, slowly, gradually growing. And when input is your time, it's almost always continuous. I'm sure there's a situation where it's not, but time is continuous. Unless you're like having money in an account that's accumulating every month, right? You get interest every month. So then it's a lump sum every month. That would not be continuous, but it's still time. State the minimum and maximum inputs, the domain. All right, minimum is 0 years, right? So the input is years. The maximum is 40 years. Okay, we're going to make 3 ordered pairs. We're going to start with 0, that's your min. And then we're going to have a max. The max is 40. And then I'm going to just pick a number right in the middle. I just choose to pick another number in the middle. All right, here we go. Notice they saved 3 points, right? That's what we did. Put in 0. Well, that's the initial height of the tree, so that's 5. Put in 20. Well, now I'm going to go h of 20. I'm going to put 20 in for the x. After 20 years, that tree is 45 feet tall. Woo! Okay, now I'm going to do h of 40. So I'm going to substitute 40 into our function, where years is. That's 80 plus 5. That's 85. All right, let's do it. Okay, 40 years. I'm going to do increments of 5. So 0, 5, 10, 15, 20, 25, 30, 35, 40. Boom. I did more than halfway. That's what I like to do. Height's got to go to 85, so I'm going to do increments of 10. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, now let's graph some points, plot some points. 0, 10, between 0 and, 0, 5 is between 0 and 10. 20, 45. Well, first I'm going to do 40, 85, which is going to be right about there. This is continuous. I'm going to graph it, and then I'm going to make sure that my third ordered pair lands on this line. Remember, your model is only good from the minimum to the maximum, right? So it doesn't go beyond that or beyond that. Okay, now let's plot that other point. 24, 5, 20. Ooh, look at that. Right there. That's perfecto. Perfecto. All right, state the minimum and maximum output values. Minimum is 5 feet. Maximum is 85 feet. Determine the rate of change. The rate of change is 2 feet per year. Per year, yep. Just had to make sure. At the y-intercept, determine the height of the tree when it was planted. That's 5 feet. 5 feet, that's your initial value. Find the height of the tree after 20 years. Hey, I already did that. I input 20 and got out 45. So 45 feet. Find the number of years it took for the tree to reach a height of 19 feet. Oh, that's tricky. Okay, so here's our function. Right, this represents the height. So I'm going to let that be 19 and solve it for my input, which is years, because that's what they're asking for. Find the number of years. Subtract 5, because now we got to solve this equation. You got to be able to solve equations. 14 is equal to 2x. Divide by 2. Oh, you can't see. Divide by 2. Divide by 2. And x equals 7. That's nice. 7 years. Ooh, I bet that's a good tree with some good shade. All right, all right. Good job, Amy. Okay, everybody, stay strong, stay focused, get those assignments done. Keep going with your mathematics. It's important. Build a future for yourself. Enjoy. Bye-bye.